Hey everybody, welcome back to the channel Tech with Marco. I'm Marco and I'm a software developer and a DevOps engineer. And have you ever questioned yourself, what if AWS Cloud would be free? So I've got the solution for you. It will be free on your local machine. So stay tuned and keep on watching the video and I'll show you how to set up your local AWS Cloud in order to save money, practice your coding skills without spinning up real infrastructure, and just have fun with the AWS API and CLI. So in order to spin up your local AWS cloud on your machine, you need the program which is called Localstack. Localstack is an awesome framework which helps you to set up your local AWS cloud on your machine, and with that you're able to develop your serverless applications in your local machine without testing them in the real cloud environment and pay money. So there are different ways to set up Localstack on your machine. Mine is using Docker or Docker Compose, but there are also possibilities to use the Localstack CLI, which is basically a wrapper and just also spins up a Docker container. And with that, you're able to interact with the AWS API after you spin up your container. It is essential that you have installed the AWS CLI because otherwise you can't interact with your Localstack container. And for that, you need the AWS CLI installed. And later, I'll show you what you have to customize in order to just talk to your local machine instead of the real AWS cloud. So let's proceed and check out the documentation of Localstack and see how it will be installed. So we have here the Getting Started section, and I think we can just skip to the installation section. As you see, we have the Localstack CLI, which you can either install with brew or, for example, with Python pip install. We have some alternatives here. There's also a GUI application, which is called Localstack Cockpit. It's not my favorite because it's like kind of unintuitive. And you can also start up a Helm chart with Kubernetes, or my preferred way is to use Docker Compose. So as you see, we have here the community edition, and it's easy as that. Just that you're using the image from Localstack, and you're mapping some ports, the entry point port, which is 4566, and some extra services port ranges, which are used internally by Localstack. You can set a debug mode for further log output, and you have to map your Docker socket into the container because Localstack is using another Docker container to spin up when you are deploying lambda functions. So that means if you're deploying lambda functions, they will be running in another separated container from your Localstack environment. And there will be a bunch of other config options, but this is just for advanced configuration and you don't need that. So another important thing, as I mentioned, is to have the AWS CLI installed. And in order to be able to communicate to your Localstack container, you can see here that you can use the AWS CLI command and specify an endpoint URL. And for that, you are just referring to localhost 4566, and then the AWS CLI is talking to your Localstack local container instead of the real cloud. But there's also another way, which is way more convenient, which is why I'm using it. You can install the Localstack AWS CLI, which is called AWS Local. And you just basically install that with pip install AWS CLI local, and then you are able to just call AWS local kinesis list stream. So that's an AWS service. And for me, that's kind of easy because you don't have to specify the endpoint URL at every command you're putting into your terminal. And now let's see how this works on my machine. So let's have a look at the Docker Compose file. As I mentioned here, we have the image of Localstack. I'm using here the latest, but to be sure that everything is working all the time, you can specify a specific version number. And I enabled the debug mode with 1. I'm using the Docker host, which is the var run docker.sock. And I'm also mounting that volume in the container that the Localstack container is able to use the Docker socket to spin up new containers. And what I'm doing here is I'm mounting an init script into the container. So init aws.sh. And I'm mounting that into a specific path, which you can look up in the configuration of Localstack. And what that does is it spins already some infrastructure up, which I specified in the init script. So let's have a look in the init script. And so I'm saying that's a bash script here. I'm just echoing something out, like creating an SQS queue. And then I'm saying AWS local SQS create queue with the queue name, my queue. I'm creating another topic. So then afterwards, I'm subscribing the topic to the queue which I subscribe. So that means whenever a message is published on the topic, the queue is listening to that and then gets the message from the topic. And I am creating a S3 bucket, which you might know. S3 is like just the block storage of AWS. You can put anything in there. So I'm just saying AWS local S3 API create bucket with the name my bucket. Yeah, and easy as that. So that means when I'm now starting my local stack container, all the infrastructure will be already there after it's spinned up. And as a demonstration purpose, I also coded a little lambda function with Python, which is just doing some simple things. So let's have a look at the lambda.python file. So as you can see, my IDE is now saying that my Bodo 3 is not installed. This is the AWS SDK for Python. Yeah, just let's skim through it. I'm initialing clients. So here is a key thing which you should do when you're working with a real AWS environment and local stack. So you can choose between a local environment or a real environment. So that means if the environment for me is local, I am declaring an endpoint URL for local stack. And this local stack hostname refers to the local stack container name, because when a Lambda is spinned up, the Lambda is running in another container and it's referring to the local stack container and it's not referring to the local host. That's the difference. So it's referring to the different container. And in order that the Lambda is able to communicate with other faked AWS services, I have to define the endpoint URL for the clients. So I'm initializing here an SNS and a S3 client, and I am specifying the endpoint URL, which refers to the local stack. And otherwise, if it's not a local environment, so for example, a real AWS environment, I'm not initializing a specific endpoint URL because the AWS SDK is able to do that for itself. And what the Lambda function is basically doing, it's creating my topic, and the AWS SDK in that case is idempotent. So that means when the topic is already there, no error is thrown. So that means I'm getting just back the topic ARN, and I can refer to that. And in the line below, I'm getting the topic ARN from the just created topic, or if the topic has existed, I still get the ARN back. And otherwise, if there is no ARN returned from the SDK, I am setting a default. And this default refers to the created topic at the init script at the beginning. So I'm just making sure that I'm getting the right ARN at all times. And what I do here now is I'm creating a message JSON here. That one has a field which is called default, and I am putting the event into that. And this event refers to the payload the Lambda is getting from my invocation call. So, and then after that, the SNS client will publish this message to the just created topic. And because at the beginning, at the initializing script, the topic has a queue subscribed, the message will be then put onto the queue, and we can read from that queue after that. And yeah, just for fun and demonstration here, I am referring to the bucket I created in the init script and just putting an object with the body of the payload I will send to the lambda function later. And then afterwards, at the end, I will return a string with the event in it, and I can see that in the log output. So let's have a look at the architecture diagram, which I just described with words, so it will be easier to understand it. So as you can see here, we have the AWS local stack cloud. And in this cloud, which I described, we will create a lambda function, and this lambda function will be able to write the event which it got with the payload to an Amazon S3 bucket. And it will also publish this event to an SNS topic. And to this SNS topic, the SQS queue is subscribed, which I did in the initializing script. And after that, we can have a look at the SQS queue with the message on it. And to trigger that lambda, so that can be any kind of invocation of some kind, like an HTTP call, for example, a GET or a POST. But I didn't construct an API gateway in my example here. So I will just use the AWS CLI to invoke function. And yeah, that's the trigger. So that can be any kind of something. So let's head over to the Docker Compose file. and start our Localstack container. And for that, I'm using the play button here in my IDE. You can also use your terminal, easy as that, but I choose to use it here because now I can also easily see the logs out here. We can see that the creating queue did work with 200 OKs. So I can see the new queue URL here, the new created topic, the subscription afterwards, and then we can see the create S3 bucket. So let's see in our AWS local, and let's take S3 LS for list buckets, and I can see my bucket is listed. And we can also do that with SNS list topics. There should be one topic, and also with SQS list queues. And we can see we have a new queue here. And the fun part now comes with the lambda function. As you can see, we have my lambda package here, my lambda function, but we don't have a virtual environment yet. So I'm heading over to the README, prepared some statements for that. So I'm installing a virtual environment for Python. And now we have a new venv folder with the virtual environment. So I'm using source venv bin activate to set my Python environment to the local shell here, to my current shell. So we can see now we have Localstack here as Python environment. And now I'm using the pip install command and install the lambda requirements text file. And in that we have bodo3 defined for the AWS SDK. And I have to install it into the target directory lambda, because when you deploy a lambda package, all dependencies should be at the same level as the lambda function. And yeah, that's just some specific AWS knowledge. Bodo3 will be installed. And now we can see we have in our lambda package here all these bodo3 dependencies. And now we head over to the lambda package directory. And then we can zip this lambda package. And that means I'm heading back now to the Localstack directory. Now we can see we get a new zip here, which is called deploy package. And in that deploy package, we have everything which our lambda needs. And now we can create a function. And I also prepared a statement for that. So we can use AWS local, lambda create function, function name, my function, the runtime is Python 3.10. The zip file is a binary file, and it's from here the deployed minus package zip. The lambda handler is lambda.lambda handler. It's declared in my lambda function, and I set an environment variable, which is then environment equals local. And I have to use the role arn. In Localstack, the role concept of IAM is not used, so we can use just some dummy data. Now I'm deploying my function here. So we can get lots of output here, and we have to check for the state because now it's pending. The function is being created. We can check that with the AWS local lambda get my function command, and now we can see the state is set to active. That means we can now trigger this function. So in order to visualize that, we can head over to the Localstack dashboard, app.localstack.cloud, and there you can register your account, for example, with your GitHub account. So I already did that, and make sure to head over to the settings tab in your account. And there you can see your custom local endpoint. And I set that to localhost 4566. The default one is localhost.localstack.cloud 4566. But I changed mine here because I'm just using the localhost standard here. And make sure to set that if you don't see anything in your system status. In the system status, we have every AWS service which is running in our Localstack container. So we have CloudWatch, Lambda, S3, SNS, SQS, or all the others like API Gateway, DynamoDB, EventBridge, IAM, Kinesis, SES, Secrets Manager, and so on. In the Pro subscription of Localstack, there will be even more, but for like most of the use cases which you when I use with AWS serverless, it will be covered with Localstack. Over to the lambda function, and there we can see that we have it deployed successfully, and I want to trigger that now. So I am heading over to my terminal, and as you can see, I'm sending here the invoke command to my function here, and the payload is JSON string, which is called then beer is tasty. So we can see some output later, and I'm using the response and saving that into the response.json. So let's trigger that lambda, and now let's check in our Docker desktop application that we can see a new Localstack lambda function container is spinned up, and in that container the lambda function will be triggered. So now we can see some log output here of the lambda container, and we can see our log outputs, which I wrote in the Python function. And we can see we initialized the clients for local environment, we sent a message to a SNS topic, and we wrote a message to the bucket. And as you can see, the status code is 200, and now I can preview the response JSON file, and in that I see finish wrote beer is tasty to bucket and send a message to topic. So that means that the function did work perfectly, and we can have a look now at our system status again and see CloudWatch, and there we can also see the outputs of our functions. And as I said, here is the log output, which I just read. There is another log stream here for the SNS SQS subscription, and this worked also perfectly here. So delivery status success. And let's head over to the system status. We can go to S3, my bucket, and I see there is an object which is called myObject.txt. And my expectation now would be that in this myObject.txt file, we can see the message that beer is tasty. I just downloaded it and preview this download, myObject.txt. Oh, that one was an old one. So the newest one is the number 2. And we can see beer is tasty. Nice. After that, the lambda function, we can also interact with the S3 API and also check the SQS message if the subscription worked. So let's see. And I'm just calling the SQS received message on my URL. And we can see that the beer is tasty was working, and that means the subscription worked also, and we can play with other API features of AWS, but in total, to sum it up, it just works easily. And as an extra, we can also have a look at Terraform configuration, for example. This means this Localstack container is also working with Terraform, which makes it very easy to integrate into your existing Terraform AWS environments. You can just extend it with some extra Terraform files, which are specific for Localstack. And this is mostly the provider configuration up here. So we have to add some mock access and secrets key here and make some configurations here, which are according to the Localstack configuration documentations, and we have to change the endpoints of the services, which Terraform is then referring to. And in my case, I did the S3, SNS, and SQS endpoint, and I just creating here a topic, another queue, another S3 bucket, and can just do that with just our normal Terraform configuration here. So I'm heading into Terraform, entering Terraform init to init the Terraform state. So after the initialization is done, we can apply our changes here. And I would expect that 3 changes will pop up now. We can create a topic, a queue, and a bucket. And there we can see all 3. And I just enter yes. We can see that the topic, the bucket, and the queue will be executed or created successfully. And let's have a look into our system status dashboard. So I would expect in the SQS that we have now a Terraform queue and my queue, which is the one which was started at the beginning of the Localstack container. And yeah, it's easy as that. So with Localstack, you're able to emulate your own private AWS code on your local machine with just a Docker container. And I think they did an awesome work there. It helps you a lot to integrate and test your functions in your CI systems and also on your local machine. And it's just helpful to play around with different AWS services if you're not in the free tier anymore, or if they don't provide any free tier for the services. You can just start playing around with it and be sure that you won't be charged an amount of money you don't like to spend for just trying things out. And yeah, I really like Localstack, and I think you should try it, experience it yourself, so that you will be able to focus more on AWS later. And I think it's helping like developer teams, like integrating all the serverless functions, because they're sometimes quite hard to test in a full AWS environment. And with that Localstack piece of software, you are able to just spin up your complete environment of queues, topics, for lambda functions, whatever, dynamodb to store data in it. And then, yeah, I think that's a great tool. I hope you enjoyed the time about your free AWS cloud on your computer. And yeah, catch you guys on the next one. Bye bye.